Casting Finials, the refurbishment of fencing on Beverley Road, Hull. Many metres of fencing are being refurbished or replaced. Hundreds of finials are required for the fencing. These are cast from wooden patterns at the foundry. Traditionally, patterns have been hand-carved. Modern methods see the finial designed on a computer and carved on a CNC router. The finial is drawn using a photo of a facsimile as reference. Once the outlines of all the features have been drawn, they can be developed as three-dimensional shapes. When finished, the software calculates the machinery toolpaths required to carve the patterns. A simulation of the finial can be viewed before the toolpaths are downloaded to the computer. A block of wood is screwed to the machine bed. The finial, as a computer code, is sent to the router. The first cut, a roughing toolpath, hogs out the majority of the wood using a 6mm ball nose router bit. The finishing toolpath carves the final shape of the finial using a 3mm ball nose router bit. One half of the finial is complete. To make a fully rounded finial, two halves are carved. Location pegs are drilled into the back of each piece. The two halves can now be assembled. The finial is now ready for casting. At the foundry, a sand mould is made from the pattern. It is made on a bench with simple hand tools, sand and a metal box called a flask. The sand is a mixture of dried silica sand, a clay binder and a small amount of water. It's often called green sand. Half of the pattern is placed on the bench inside, one half of the flask. This top part of the flask is called the drag. A white powder, talc, is shaken over the pattern. This stops the sand from sticking to the pattern. Space is allowed around the pattern to allow a riser to be placed next to the pattern and a piece of wood which is called a runner. The riser allows excess iron to raise above the cast of the finial when pouring, and the runner forms a channel in the sand for the iron to run from the pouring hole to the mould cavity. A first layer of fresh sand is sieved over the flask and pressed around the pattern with fingers. Recycled sand from previous metal pours, hence the black and burnt look, is shovelled into the flask. It's rammed with a hooked bar and hammer. More sand is shovelled into the flask until it's overfilled, and finally rammed with a flat-ended tool. The top is scraped flat with a metal bar. This is called striking off. Holes are stabbed into the sand. These are vents which help release the hot air created in the mould when the molten iron is poured in. The flask is turned over. Scoops of sand are taken from two corners. This will help locate the two boxes when the two halves of the mould is assembled. The other half of the moulding box is placed on top of the bottom box. The other half of the finial pattern is positioned. A cylindrical shaped former is positioned butting up to the end of the finial pattern. Talc is shaken over the box and the first layer of green sand is sieved into the flask. A rectangular shaped former is placed at one end of the runner. This will form a void in the sand where a filter will be placed before pouring the metal. A copper tube is placed over the rectangular former and held in place while the flask is filled with sand. The sand is rammed and stricken off. The tube is removed. This forms a hole in the mould where the molten iron will be poured into during casting. The hole is called a sprue. Any loose sand is removed and the top flask, called the cope, is vented. The flasks are separated. The patterns are removed, leaving an impression of the finial in the sand. The runner and riser blocks are removed and both moulds are cleaned. A filter is placed in the square void. This will catch any impurities in the molten iron, stopping them from spoiling the final cast. The moulds are given a blow to remove any loose sand. The mould is assembled and placed on a sand bed on the floor. The moulds are given a blow. Pouring cups are made glued over the sprue, and weights are placed on top of the sand mould. They hold the top flask in place and stop it lifting up when the hot air is escaping from the mould during pouring. The mould is now ready for the molten iron. At the foundry, pig iron is loaded into a wheelbarrow. The crucible is placed into the furnace and charged with the ingots of iron. The furnace is fired up and will take approximately 2 hours for the iron to reach the pouring temperature of approximately 1650 degrees centigrade. This furnace is heated with oil. The temperature is raised by blowing air into the bottom of the furnace. The furnace is lined with fire clay or ganister, which can withstand the high temperature required to melt the iron. Scrap iron is placed onto the top of the furnace to pre-warm it before placing in the crucible to melt. The pouring ring is prepared. The temperature of the iron is checked before the crucible is lifted out of the furnace and placed in the pouring ring. Dross is scraped off the top of the molten iron before it is poured into the mould. The iron is left to cool for 10 minutes before the cast is removed from the mould. The used sand can be recycled to make further moulds by mixing it with some more green sand and a little water. The runners and risers are cut off with an angle grinder. The seam is grounded off with a linisher. The cast is fettled with a combination of a hand sander and files to remove any sharp or rough edges. The finial is now ready to be welded onto the fence. This demonstration shows one finial being cast in a flask. In production, 6 to 8 finials would be cast in a box to reduce time and cost per item.